and welcome to the stream. If you're new here, I am Jared. I have been writing for Ruby for quite a while now, and I run a software consultancy where we build e-commerce websites using Ruby on Rails and a platform called Solidus. That's not what we're doing today. Today we're doing Advent of Code problems because I need to catch up on days 17, 18, and 19. And am I muted? I don't think I'm muted. My levels don't look like I'm muted. What are you seeing, Jiggins? Or hearing? Is there maybe a good amount of lag or something? Because it only now shows one viewer for me. Probably just you? Okay. All right. We're catching up on days 17, 18, 19. And then I'll come back and do day 20 this evening. I had various things going on this week, so I usually take sometimes Thursdays and also Fridays off of streaming so that I don't have to stream every single night. As is usually the case, I have some whiskey, so I'm working through a whiskey advent calendar. This is the Tobermory 12. Had not heard of this one, but it is very, very tasty. They also make Ledaig, which is very nice. It's a very nice it's a cost-effective peated whiskey, peated Scotch. It's not super expensive. It's pretty good, but it doesn't cost a ton. With that, I think we can probably get into our first puzzle for today. Day 17, Conway cubes. As your flight slowly drifts through the sky, the elves at the Mythical Information Bureau at the North Pole contact you. They'd like some help debugging a malfunctioning experimental energy source aboard one of their super secret imaging satellites. The experimental energy source is based on cutting-edge technology, a set of Conway cubes contained in a pocket dimension. When you hear it's having problems, you can't help but agree to take a look. The pocket dimension contains an infinite three-dimensional grid. At every integer three-dimensional coordinate, there exists a single cube which is either active or inactive. In the initial states of the pocket dimension, almost all cubes start inactive. The only exception to this is a small flat region of cubes, your puzzle input. The cubes in this region start in the specified active or inactive state. The energy source then proceeds to boot up by executing 6 cycles. Each cube only ever considers its neighbors, any of the 26 other cubes where any of the coordinates differ by at most 1. For example, given the cube at x equals 1, y equals 2, z equals 3, its neighbors include the cube at x equals 2, y equals 2, z equals 2, the cube at x equals 0, y equals 2, z equals 3, and so on. That makes sense to me. During a cycle, all cubes simultaneously change their state according to the following rules. If a cube is active and exactly 2 or 3 of its neighbors are also active, the cube remains active. Otherwise, the cube becomes inactive. If the cube is inactive, but exactly 3 of its neighbors are active, the cube becomes active. Otherwise, the cube remains inactive. So yeah, basically Conway's Game of Life in more dimensions. The engineers responsible for this experimental energy source would like you to simulate the pocket dimension and determine what the configuration of cubes should be at the end of the 6-cycle boot process. For example, consider the following initial state. Even though the pocket dimension is 3-dimensional, this initial state represents a small 2-dimensional slice of it. In particular, this initial state defines a 3x3x1 region of the 3-dimensional space. Simulating a few cycles from this initial state produces the following configurations, where the results of each cycle is shown layer by layer at each given z coordinate, and the frame of view follows the active cells in each cycle. Okay. Sure. Excuse me. Yeah. After the full 6-cycle boot process completes, 112 cubes are left in the active state. Starting with your given initial configuration, simulate 6 cycles. How many cubes are left in the active state after the 6th cycle? To begin, get your puzzle input. Oh, I didn't finish setting up here. Sorry, I have to... what do I have to do? I have to connect to my laptop. Where's my laptop? It's certainly not on. 1 second. I didn't think about this at all. Okay, laptop acquired. Sorry, I just got home from running errands, so I had not set everything up yet. Oh yeah, yeah. When I got my camera's set up to like, how do I do this? Focus on that area of the screen roughly, and just try to put whatever's there in focus, and as such, you get to see the background when I step away. Let's connect to the right thing. And now I can show you my screen again. Lovely. So set up our binding. We're doing day 17 part 1. Can run that. Generate our day 17. And so I guess it doesn't particularly matter, but this represents just a 2D slice of the 3D space in, yeah. And it doesn't matter. I guess it doesn't matter because we're just counting the number of things. Okay. How do we want to test this? Kind of want to parse it initially. How do I want to store this though? It's my question. So I mean, we've got some sample inputs. Let's take our sample input. Oh, this is our sample input, and put that into here. Pouring rain here right now. Nested hashes. Nested hashes is probably the, I don't know, it's a reasonable way to do it. So what's the language we use? Configuration. Yes. So yeah, the setup I have, so there's like a light strip on the shelving behind me and one along the back edge of my desk that just provides some nice sort of color to the room. Then the desk itself, I could use better lighting on my face for sure, but it has just sort of like two arm desk lamps on either side that light my whole sort of desk so that I have good lighting for, you know, taking notes, things like that. And then behind me, there are 3 arm lamps mounted to the top of this shelving unit and shining back at it. So can't really see here, but there's like one, that's why one's lighting the corner, one's sort of lighting the plants in the middle, and then the stuff off screen is also lit by a third one. And they're all like smart lights. So nice camera does help quite a lot, but they're all smart lights, so I can kind of control the colors. In the summer, I end up like, here, let me show you. Like when it's super bright in here, I'll end up like doing something. It'll be like more like this, where it's like super blue looking, but that looks good when there's like really bright sunlight in here. Whereas, you know, in the evening I go for like really orangey vibes, more like that. And then on like a rainy day, I just try to sort of not go too far, but sort of add some warmth to the scene. One thing I want to do is find a way to control the lighting based on the weather. I use Home Assistant. I have Home Assistant running on a computer behind me, and I really would like to find a way to like do some automations that are like, oh, it's gray and rainy, set it like this, or like, oh, it's clear and sunny, go for the other lighting or whatever. It's just fun stuff to fiddle with. It's not like changing the light colors takes any time, especially if I like set up different automations that I can just trigger. So we can put our solution into here. Yeah, Amy found a really, like, especially since she's not in a really bright room for her office, it only has one window. She got like a pretty cheap sort of light, like fill light kind of thing that works good. I want to get something fancier, but not super fancy. There's those like key lights that cost like $300, and I'm not already spent enough money on the streaming setup. Maybe I should get that, but I'll get something similar, probably a little more cost effective though. So I guess we've got a reasonable test here, and some kind of syntax error because I wrote the word class up here. Okay, so we know it doesn't compute the solution yet. What language are these? Pocket dimension, cycles. I mean, it's the state of a dimension. I'm just gonna use state. It's not a good name for that, but okay, what are we doing? There we go. And then let's test parsing. So I'm gonna say state I have a question here. Let's do a little experiment. So you can do hash.new, and I'm thinking we're going to rely on this, where let's say empty hashes return foo. Is, and then let's set a key here to that foo. So h.bar, that's foo. Is this? So that's going to be equal, right? But what if I do other ones? I'm going to say it probably isn't, but I don't know. Yeah, okay, that's not equal. And that wouldn't be equal. Interesting. Okay, I kind of, whatever. That's not going to be equal. So I'm just trying to figure out how to like best evaluate that we are actually parsing this correctly. So let's take our sort of sample input down here. Say state parse input. We want it to be equal to state new. And I don't know what I'm actually writing here. How are we gonna store this? We're gonna store it as like XYZ nested hashes or something. So it'll be like this would be 0. What are we gonna make 0, 0? This one? We're gonna do like graphics 0, 1, 2, or are we gonna do 0, -1, -2, or are we gonna do 0, 1, 2? It's always hard to think about. So, well, we know that it's gonna be X, Y, Z is what I'm gonna want to store things at. So maybe we can say state equals state.parse, and let's not worry about how we're implementing it now. Let's say state.get. We'll have to build multiple pieces of this API out to make this test pass, but state. I mean, we can just implement. We can just YOLO it. Or you can do this, can't you? So we want 0, 0, 0. We'll just return booleans, I guess. Assert equal, or just assert that. Let's try one. So this is 0, 0, 0. This is 0, or sorry, 1, 0, 0. It's also full. So is 2, 0, 0. I guess we can just do the whole thing. And then we want only these y coordinate is 1. And then for the final one, we want refute is the first one, assert is the second one, and refute is the third one. And that's, oh boy. Okay. That's a kind of fun API. I think we can make this work. I think this is valid Ruby. So first, we're going to define self.parse, and also initialize. I don't know what I'm going to call this. Yeah, the fact that we called this thing state is probably a bad idea, but. And then we're also going to implement this. And this will fail because this doesn't return input. Perfect. All right, now we actually have to do something. Let's take a look in here. Or I guess I'm still stuck thinking about the structure that we need. Is it just a bunch of nested hashes that return more hashes? I think so. So like hash.new, like, is this what we're writing? I think so. I mean, I think this is gonna work. We actually need to populate this hash. Interesting. So you split it into two different hashes that store different information. I'm not sure I understand what the different information would be for part one here. But I'm intrigued. Then let's say input dot split on new lines. I mean, I'm fine with, you know, spoilers of other people's approaches. They might, you know, you're allowed to say whatever you like. I want to reverse the lines though. I also have a pretty good idea of how I want to do this. I have implemented the game of life before, not in more dimensions, but in 2 dimensions. So I'm sort of comfortable with how I want to approach it. Line chars each with index do column. And what's next? Then we want to say H hash was ever expanding grid, and the other hash stored all neighbors of a particular coordinate. Ah, that's an interesting way to do it. Makes sense. So we know that these are all at z index 0. So we need to just put the column, then the row, then the number 0. And we need to set that to true if x is a hash. And then we just that. I think that probably does something like what we want. Wrong number of arguments, 4 expected 2. Yeah, that's fair. That is what I meant to do. Oh, I have to do the thing. Gonna go read my own blog. Remember how to do this properly. All right. I want to do this. How do I write this? H equals hash.new, and then each of these are going to be nested, so it's going to be kind of awkward, but does the lowest one need to have default values? No, I don't think so. Something like that. One hash was oh yeah, no, sorry, I thought I had a new comment. I'm just reading your same comment again. Yeah, I don't think you need to do it as separate ones, but it's possible that doing so makes your implementation faster or something, depending on exactly how you do the sort of stepping through it. Okay, expected nil to be truthy. So this is not returning anything right now. So how is the best way to do this? Chords dot inject. Oh, using Z is going to be confusing though. So it's accumulator second. That do what I want? Apparently not. Expected on time, no plus convert hash into integer. Okay, let's just see where we're at here. So state is going to be the sort of nested hash where we see 000 is true. Did I do accumulator and I backwards? Yeah, I did. Okay. Sweet. Okay, so we have a state that looks, we have like we can parse the current state and expect it to be in, I don't know what I don't even know what words I'm trying to say here. We have parsing working. Sorry, I needed like a quick sneeze button. So now we want to test cycle or whatever we want to call it. So if we do the same thing, but then cycle we want to have I'm doing the same thing where like my states are immutable. When you call cycle, it returns you a new state that's in the new thing, because like I don't know what we're gonna have to do for the next one. I kind of have I have some insider information because it's impossible to avoid spoilers for this, and I don't really intend to, but you know, should I need to look at should I need to do branching paths or anything like that, it's much easier to do it this way. So how are we going to do this? This is the tricky part, because it's an infinite space. I see where you might want to get into the game of storing all things, but at the same time, we have enough information to generate all of the different positions that we might care about, right? Pretty efficiently too, I think. So let's set up our test though. For any cycles we're there, and then after one cycle we're here, so we can turn that into a test. Let's sort of just copy that in here and write a test based on this. So we can say something sort of like what we did before. It'll be a really ugly test, but so we can say for z equals 1, we want, let's arrange these the same way. Oh, that's not even right. So this is the first row, 0, 1, 2. Yeah. So we want assert, refute, refute, and this is for z equals 1 here that I'm doing this. So or sorry, z equals -1. Make sure that doesn't mess anything up. And then the second row is typo is refute, refute, assert. Perfect. And the final one is refute, assert, refute. Nice. Get rid of that. It's gonna be a beautiful test here. Maybe we should keep that actually, just for making this at all readable after the fact purposes. Because I can't imagine this is going to be easy to get exactly perfect. So we assert, we refute, we assert, we refute, we assert, and then we refute, assert, refute. Perfect. Go. One last one. We should have a reasonable looking test to at least prove that we can move one cycle forward. And so this one is z equals 1. And why is my syntax highlighting doing something weird? All of the numbers in the middle one are not, whatever. Assert, refute, 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 assert, refute, assert, refute. Perfect. All right. No, we're not upgrading iTerm in the middle of a stream, but thank you. All right. And finally, let's assert state.count is, wait, why did I do that? Assert equal, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Cool. Okay. So this is where we need to do the fun stuff. So cycle is going to do something like, we need like a possible coordinates. And then we need like neighbors or neighbor count for coordinates, and that's going to return a number. And then we can do something like, let's just say, let's extract that into a reusable method. That is an ugly piece of logic, but we do kind of need it. So we'll say h equals new h here, and in cycle we will say h equals state new h here, and then we just have to fill in the stuff in the middle. All right, easy. And the stuff in the middle is going to be something to the effect of possible coordinates dot each do x, y, z, if state, or if self x, y, z, else something else, and then we're going to say like if h, x, y, welcome back chickens, z equals true if, so this is in the true case. What are our rules again? Active has exactly 2 or 3, then it remains active. If 2, 3 dot include neighbor count x, y, z. And in the other case, we're going to do something similar. We are going to set it to true if neighbor count xyz is equal to 3. Almost did 3 equals. There's a thing where people who write C code often put the like literal parts of their equality checks at the start, so that it's a syntax error if they accidentally forget to double equals rather than a assignment. So I think that's our basic algorithm. If it's alive, we set it to alive if it has the correct neighbor count of 2 or 3, otherwise we let it die. Okay. Possible coordinates. So coordinates can only become live or die if they're within one distance of a live cell. And we have a hash that contains all of the live cells. So like, I feel like we can figure this out. I have a syntax error somewhere. Unexpected else, expecting close paren. Yeah, I forgot to close this paren. Cool. So I have the state thing. State dot map, and then we'll have the x value and the whatever rest. And we want to say rest dot map. Then we have the y value and the rest. And then the rest map the Z value and we don't care. It's going to be like the value true. So and we just want X, Y, Z. So this is all of the populated coordinates, I think. If maybe I close everything. So those are all the populated coordinates, because we only set them if they're populated. But these should all be flat maps. I think. The outer two should be, because I just want the... Yeah, there we go. Array of coordinates. Okay. So this is like coordinates that exist, which is a start. Let's say live coordinates. That. And can memoize everything. Just in case. So let's do that again. Now we have a list of live coordinates. And so we care about, we need to be able to get the surrounding coordinates of a given coordinate. So maybe that's the next step. Maybe we need to implement a method that does that. So def neighbors of a given set of coordinates, because then this becomes live coordinates dot flat map do X, Y, Z, or I can just do chords. So do that, and then I can map them to the coordinates themselves and the neighbors of those coordinates. And that's just what that is. We can call it .unique on it if we want. Probably worth it. So we don't do any duplicated work, but I really like the Squatch today. A little peaty, but very manageable. Okay, so that's that implemented. So now we just need this to work. So this gets called with coordinates 0, 0, 0. So how we do this? We have an X, or each with index. So it's a coordinate and a index. I'm trying to visualize how I'm supposed to do this. And then we're going to map it to do I just do a recursive? I'm so used to just using recursion. Let's do it. Let's try and write it with recursion. Disable or just exit. No, disable pry. Cool. So how does this work? We call like some function. I don't know what I'm gonna call it. With coordinates in that function says if, so return, so if chords.length is 1, then we're going to do something. We're going to return, maybe I should do the regular case. Otherwise we call it with oh boy, come on brain. This is usually a reasonable way to generate these like things. Just having trouble today. Okay, I can do the base case. So at the base case, we need to return -1, 0, 1 map. So that's the possible tails, right? And maybe the maybe the coordinate. Okay. Flat map. Foo chords 1. Oh, this is ugly. Dot map. I don't know why I'm switching between do end and curly braces and mid method. Well, this is hideous. But maybe right? I don't know. Let's find out. Where am I calling it? Our structure is a little different, so this might not help, but it was really happy with -1, 0, 1 repeated permutation. Oh yeah, you could do that. That's another way to do it for sure. It's probably even more efficient than what I'm doing, but you know, we're here now. So, what does this return? That looks right. Should be same. Unique, yeah. This looks like everything adjacent to... Because there should be, what, 24 of these? 27 of these. Sus. or sorry, there should be 26 of them, but this is currently including the element itself. Ha, there you go. So that actually looks like it worked, but we need to remove the coordinates itself from whatever we return. Is that how I do that, or do I do that? Probably that. So day 17, we have a failure in the very beginning of our tests. We have a failure. And that's probably because neighbor counts just set to 0 always. So this one is now neighbors.count. We're going to count the coordinates where state, or I guess self, I don't know why I've passed the coordinates right now like this. This is not an efficient way to do this. And I have a method named foo. So, all right. So now line 112 fails. And that is the exact same line. So that's obviously not our solution. So let's just take a look at what we've got. And we may want to just visualize it. So these are X values. So Z, we see was it a live count? What did I call it? What was it? I called the method no, not neighbor count. Possible coordinates. Where is it? I don't have a method that does the thing yet. Well, that's silly. Anyway, do a sec. Sorry. So it produces something. It's possible we have the rules wrong. Sorry, I have not. Oh, there we go. I had a hair in my mouth and it was really unpleasant. Okay. Should we like implement a visualize method? It's kind of tough though. What's the failure reading? I mean, it's just failing tests. So line 112 fails. So it expects to find a thing in this position, but it does not. What if? Okay, what's going on here? Yeah. It's also possible that my indexes are just backwards. So like double check that fails at. No, that's still failing. They all should have a thing at 0 to -1. right? Let's go a little quick read on the puzzle again. Initial site after 1 cycle, yeah. And that has become alive. Isn't it supposed to come alive if it has exactly 3 of its neighbors are active? What? This. Oh, is their example wrong? Is that a thing? Example is not consistent in its coordinates. It's only showing the bounding box of active cells. Oh. For real? So then what am I missing here? What coordinate is this then? The frame of view follows active cells in each cycle. Why would you do that to me? Okay. While I find the decision offensive, I will figure this out. So this one's definitely going to be alive. And as is the one below it. Which means that this is actually... This can see 3. This can't see 3 though. Oh, it can see 2, right. Yeah, I think maybe my solution's right, but well, let's do it. I want this. So this is now, I can fix z equals 0. That I know how to do because it is just shifted up or shifted down, depending on how you look at it. So this isn't column, or this isn't row 0. This is row -1. So I just need to subtract 1 from all of these. So happens if we test that. That works. Okay. So we probably have it right. We just need to implement a count method. Count is going to do care about the values. I don't care about ghosting them here. Yeah, that worked. Okay, so we'll throw away all of our extra tests. Because it's difficult to set them up, and what we have is actually working. So that is funny. Now we can just write the test. State.new. Typed state so many times now. Input. I'm supposed to not dot new. I'm supposed to parse that. That was what, 6 times? One gold star. There we go. So it works. That's awesome. Day, what are we on? Day 17, part 1. Let's do part 2. For some reason, your simulated results don't match what the experimental energy source engineers expected. Apparently, the pocket dimension actually has 4 spatial dimensions, not 3. The pocket dimension contains an infinite 4-dimensional grid. At every integer 4-dimensional coordinate, there exists a single cube, really a hypercube, which is still either active or inactive. Each cube only ever considers its neighbors, any of the 80 other cubes where any of their coordinates differ by at most 1. For example, given the cube blah blah blah, its neighbors include the cube blah 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 blah. Initial state of the pocket dimension still consists of a small flat region of cubes. Furthermore, the same rules for cycle updating still apply. For example, yeah. Got it. Do it for 4 dimensions now. Okay. So does this do it for the same example? Does it for the same example? Yeah, there's a flat regions in 4-dimensional grids. This isn't my first time around extra dimensions. I did get far enough in university math to have to like rotate things, you know, formula or like whatever it was. There's that where you take like a line, like a formula that represents a line, an equation that represents a line, and then you have to like rotate it around something in like 4 dimensions to get its like volume or whatever. That stuff was, I've taught my brain to I've gotten as far as just, you know, forcing your brain to ignore that you can't actually visualize 4 dimensions and just try to like follow the rules for how extra dimensions work and not try to think too hard about it. So our sample input is the same. So we can actually write a proper test for this one again. After 848. Very cool. So we have this. And I think we just start trying to like parameterize this thing. Fix anywhere that we've assumed the number of dimensions. So I think we need to start just passing in the number of dimensions to this class. Let's just parameterize it. This is going to be tricky. I think we can do it though. So first, let's just remove all of the references to extra coordinates or extra stuff here. So this becomes chords again. This becomes star chords. This we're gonna have to fix. I don't know how we're gonna do that. This becomes star chords. This becomes star chords. And we don't really reference XYZ except for here. And no, those are just extra values. So that should still work for part one. No, we've wrecked everything somewhere. Probably up in here. Yes, we need to fix this thing I said we need to fix. We need like a nested, a utility function that's just like a nested set. I mean, so we're always going to be setting true. So let's just take in the hash and the coordinates that we want to set, and this can be replaced with call to state. And then we just have to figure out how to do that without ever referencing the individual or like caring that there's exactly 3 coordinates. So target equals chords. So we take the first, take everything but the last coordinate, inject H, I think that gets the target, and then we can say target chords dot last equals true. Odds that broke everything. And if I'm at the nested set, or I called it nested set down here, it should be sign. Okay, so the failing spec is just that we haven't implemented part 2 yet. Okay. Oh, we can use that up here as well. Where do we want to? Nested assign column row 0. That'll work currently, but not for unlimited dimensions. What? Oh. And that is because I forgot the API of the thing I was using. Okay, that should work. Okay, cool. We've still not broken our thing, but I think we've removed all the explicit references to XYZ in here. The next one is that our nested hash structure is not dimension aware. So that presents an interesting issue. I think fixing this is going to blow up my brain, but you know, let's do it. Actually, I want to fix this part first. I think I'm close enough that I can do it. So add a dimension parameter. Let's make it required. And then where are we at? We need to go pass that in wherever we use it. So that's going to say 3. That's going to say 3. That's going to say dimension count. And we'll make that a dimension count. And then we just need to pop that into here. And we'll say it's 4 dimensions. Still shouldn't break anything. And now this becomes dimensions minus 2 times map 0. Beautiful. Thank you, Voted Boa. I have this is a Canon mirrorless camera that I'm using as a webcam. Undefined method square equals for nil class. Yes. And that I expect to be the error for part 2, because my nested assign no longer works because my new hash is not deep enough. I do want to generalize this, even though I know I could just put it if the dimension count equals 3 here, which would be kind of a cop-out, but I could do it. So dimensions times inject. I believe in this. We can do this. Do accumulator. Don't care about the other thing. And we're going to return wrong number of arguments 0 given 1. Everything's erroring. Line 15. Oh, I'm not actually calling it with the number of dimensions anywhere. All the other references to new hash. Cycle. I guess I need to record the dimensions on somewhere so that I can reuse them. That's kind of unfortunate, but we can do that. We'll pass it into new. We'll pass it into the constructor. Lovely. And then inside of here we can call add dimensions. And that is our only references to that. So now everything's blowing up for some new reason. Where do I start? Wrong number of arguments. Line 26. Okay. 46. Dimensions. That is that what that is. So what am I missing? Oh, this is count is already iffy. I guess anywhere I see a nested loop, I should know that that needs some additional thought. So like live coordinates and count also don't work. Cool, cool, we can work with that. Oh boy. This is tricky, this is tricky. We've now broken this for everything though. I would expect the day one stuff to still pass though. Getting 0 everywhere. What if I've made a mistake? State test parsing. Expected hash not to be truthy for state test. So that suggests I did this not quite right. I think new H is not working correctly. Yeah. That is not correct. That is one too deep that I'm finding nils in there. Didn't fix it though. Need to fix that one issue though. H0 should be a hash, H00 should be a hash, but H000 should be nil. Okay. So that works. So then let's test our nested assign then. I guess we could just test it. I guess I could have done it right there. So H, so we want to do nested, assign, H, and then array, coordinates, so. That works. What if we make, oh, that should just work. Yeah. I've only set 3 values, but there are 4 trues here. What? 0, 0, 0 is true, 0, 0, 1 is true. 0, 1, 0, 0 is true, and 1, 0, 1 is true. That's wrong. How did this happen? Let me go look at how I'm constructing this hash. One day I'll type disable pry correctly on the first try. I believe in us. So new H. Oh, it's reusing. Dang it. I knew that was going to be the tricky part. How do we do this? This isn't quite right. So we have like a base case. We have like the lowest level. We want to be just creating new hashes without any extra logic to them. What do we do? Excuse me. What am I supposed to do here? Oop, jumped in the wrong place. There's the dog. Good. I don't know why she's barking. If I think we need to put a conditional in here. I think that's the only way we can really accomplish this. Times if so if we're on the last if this is ugly. This is really hard to wrap your brain around, I think. I don't even know if I can do this way. Oh man. Okay, I believe in me, but boy, this one's stretching my brain. Let's play around and pry. So maybe I need to be inside that loop to really make any progress there. So we have an accumulator, which is a hash. But that's not actually what we want here. It's if okay, let's try a couple things. I think this is wrong. I don't think using accumulator works, which is my issue. But let's say instead of nil, let's say if accumulator is nil, then or I guess it's the same as this. I don't think this works, but I think I'm getting closer to what I care about here. So H nested assign H, and then we'll try 0, 0, 0 to start. Examine it. That works. 0, 0, 1 works. But what happens if we do this? I think that's going to be wrong again. Yes, it's still wrong, but I think I understand what I need to do. I need to build up the block, not build up the... I can't use... That's hard to explain. So that's our base one. Oh, mine will be cooler because mine will work in like unlimited dimensions. So the cost for cool is, you know, any cost is worth it. Exactly. Can't put a price on cool. Am I making any sense here? I'm trying to figure out what the hell I'm doing. It's an invalid ruby, so obviously not. I feel like I'm close to something, despite this entirely breaking my brain. What is this supposed to be? It's supposed to equal a hash new with... This is wrong. It's gotta be wrong somehow. Maybe -2 this? Then it's right? Whoa. Okay, what is it so upset about? Syntax error, unexpected. Oh, because I just forgot Ruby syntax. Whew. This looks suspiciously like it's working. But, moment of truth. Oh my god, that works. So if you're wondering, if you're watching this and wondering why exactly this works, good luck. I got there, but now everything's still erroring. So this obviously isn't the final solution, but it appears to superficially work in my tests, and now I have to figure out what I've done wrong somewhere. That it's breaking completely otherwise. But I think we're closer. Also, sadly, the light change in here was, that's what happens an hour before sunset. So nested assign is failing. That could be, we didn't chest one aspect of our hash builder here. So this is not right. We can no longer do lookups. What? This is, okay, so this doesn't work. This is just very wrong. It only works if we're only assigning. So assignment is working with this thing, but is there like a, I want to like inspect it. Okay, this doesn't work. Ah, gosh darn it. I thought I was so close. This does not work at all. Why do I just get 0 out of... How could I possibly be getting zeros back from this hash that I'm building? Oh man. All right. Should I just go back to the thing I know works? Okay. Let's do it this way. Maybe it'll give me some insight as to why this is not working. Yes, it's just the same line again. Oop. Okay, let's get rid of that pry. See where we're at, see what's going on. So everything is passing except our last one. Which is interesting. I kind of thought we were all the way there. Dimension count is 4. Getting 0. That's super sus. Oh yeah, I remember now. This. So this isn't let's just give up on the general solution here. For now. Maybe I'll come back and try and so that's one way. So that should give us at least a different result, or maybe not. But this is where we're doing so good, but these like nested lookups are so hard to do arbitrarily. Okay, let's unroll this so that's a little easier to work with. So we can inject our last layer in there. What's our lowest level coordinate called? Live coordinates. Rest. This will be A. Okay, and so that gives us A there. It's one more that should not break the existing code. Neighbors works fine. Foo is recursive, so it works fine. Still getting 0 on my part 2 test. What am I missing? Like, I can run part 2 even and get 0. What the heck? None of this. None of this looks like it's I have to just start digging in. All right. Let's say binding.pry if dimensions equals 4. Cool. So we have our existing thing, we have our state, which is empty, and that's wrong, right? Why would be cycling on an empty state as the first thing that happens? Seems strictly wrong. What? The heck? So we're not even parsing correctly. Okay, cool. Okay. So let's let's take a look. So we get a new thing. Do I want to just, do I not pry in there? I guess I probably do. I guess that's what I should have done. Okay. So we have a column, we have a row. What is the value of this thing? Is it wrong? No, that's 0, 0, 0, 0. That looks right. Is this condition true? Yeah, so we're gonna call this and expect something to happen, and nothing happens. So our nested assign is not working. Let's see what it's getting called with. That's expected. I already tested that was working. Okay, let's go take a look at it. Nested assign then. Nested assign. Cool, and that's the H we're expecting, that's the chords we're expecting. Chords 0 to -2 is those. So that's sort of what I expect to work. And then we do so target is this hash, but target 0 equals true is going to do nothing to H. Right. Why is that? So if I do H 0, 0, 0, 0 equals true, I get nothing. Okay. So like the basic thing that I had working before is no longer, does not work with our 4-dimensional one, but is continuing to work with our 3-dimensional one. So that is because I forgot, I did not do this properly. Oh, come on, computer. Don't go to sleep on me while I'm using you. I forgot to write hash key equals there. Cool. Different error. At least. Here's my prize. So we are still only failing part 2. And so let's look at where we're failing. Day 17, 117. No implicit conversion of integer into array. Let's rescue. Called with an array of coordinates instead of So that's wrong. Because it should only be getting called with a set of coordinates itself, right? And then it returns an array of coordinates. I thought I installed... Hey? Yeah, you're gonna error, I understand. I swear we added Pry Stack Explorer. At some point. Must have been that one of the times I get reset. So up, and we're calling it with that, up. What is it? I guess that's not a thing. Okay, so we're missing some flat mapping somewhere. Okay. Let's leave that. Yeah, that's probably it. Well, it didn't produce the right result, but it also did an error, which is sus. I'm gonna throw that in just to test. I assume that it's wrong, but answer's too low. Yeah, just like our other one. So that's good to know. Let's try, I don't know, where do we want to debug this? Dang, this is tough. Jiggins is right that I made this way, that I made this harder on myself. Where do I dig in to try and debug this? And we can do our initial test like we did before. So we want to know that we can do like a nested assign for like H and then an arbitrary location, 4 dimensions. This is probably a 3-dimension. Oh, this is a 4-dimensional example. Okay, cool. That works. That works. That works. That works. And presumably that also works. I guess we can test this to make really absolutely sure, but yes. This is our sort of structure here is returning the right things. And now we should be able to get them out. Yeah, and we won't try them all, but let's try this one as well. Is that one supposed to be set? No. 1 supposed to be set 1 1 0 and just try a random other one. So that is working as intended. Oh yeah, that resulted in a super wrong number just because I interfered with it. It's also not fast. Getting way too low a number. How do I debug this? I guess I can write a simple 4-dimensional test and then see where I'm at. Test cycle, and we'll say def test cycle 40. And let's sort of copy this. We'll need to change it a bunch. I didn't ever check that, but that's a good point. I used a recursive I used a recursive function for that though, so I don't expect it to be wrong. But you are right, I should check it. So for any cycles this, and then after 1 cycle, I care about z equals 0, w equals 0, which actually should be the same, right? Because there are no, this I don't think I can assume. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, I lost count. 3, 6, 9, 12, 13, 14, 15, 16, 17, 20, 23, 26, 29. So it looks like there's 29 after a single cycle. And so that's just like fundamentally not working. But it is working in the base case, which is kind of interesting. Did I make my count method work correctly? I think so. Let's just double check though. Let's just take a look at it. Sus. What? Oh boy. Oh boy. Look at that. Look at that. Assigning it. Should have done the thing I was talking about before. Now I got wholly different wrong numbers. Didn't do this anywhere else, did I? Okay. No. Okay, well that's fun. Good to know. Still want to do a little test though. Call it. Woohoo. Yes, yes. Oof, indeed. So let's just try it. So that's presumably some wrong number we've computed. I don't know, I don't expect it. issue to be there, but it's good to know. Okay, so next one was possible chords. Or actually, no, sorry, that's not the one. Neighbors is the one we wanted to test. Where's a good place that we call neighbors? Oops, I spelled binary wrong. There we go. And I wanted 4, not 3. I did the opposite of what I wanted. So that's good. And now we can say, so we've got some coordinates, and we want to know all of the neighbors of those coordinates. Uh-huh. You say there should be 80. There are 80. And we can check if they're all unique. I think that code works. But good thing to check. Rule that out. Jeez, we had this one for a long time here. Put it in. Too high. Just trying to figure out what the next sort of seam to try and dig into to figure out where this might be broken is. I'm just formatting these two separate blocks consistently for my brain. More borks. 5 coordinates, which that's not any different. Count, that's good. This doesn't even care about n dimensions. Yeah, the tough part is it's working in 3 dimensions. There's just something subtle not working in 4 dimensions. Guess I can try and assert something about the extra dimensions down here. Maybe this is where I have to just bite the bullet and brain a little hard to write a better test case. So say Z minus 1, W minus 1. Let's do that one. Oh, that's not gonna work. Let's just do it this way then. Okay, and those all stay the same, and we just need to fill in the blanks here. So I'm just gonna change them all to refute, and then mark the 3 that we care about. But first I have to figure out what they're supposed to be. So, well, they have the same offsets, I think, because that can see the one that's through this one can see 1, 2, 3, 4, can't it? That can see all of them. What can see what can see 3? That can see 3. And that can see 3. And that can see 3. Okay. I see it. I see it. So if I take this and so the ones that are true are 1, 2, 3, or sorry, 0, 1, 2, 0. So it's 2, 0. This is 2, 0. I think. So let's just try and make this make sense. So 2, 0 is legit. This one. 1, -1 is legit. And this one, 0, 1. So whatever, I don't care. Let's just see if that passes. Then we'll figure out whether it's worth writing it. So that's not ending up truthy. Okay, so at least we can see things in the other dimensions not working as intended. Sure, I haven't missed anything rule-wise. 1, 2, 3, 4 would be neighbors to 2, 2, 3, 3. Yes. And 0, 2, 3, 4. Sure. Yeah. During each cycle, consider the number of active neighbors of each cube. The rules are the same, right? Yeah. They're using W. I used A. I should switch that. Not that it changes anything. Here we go. Okay. So does your new part 2 solution value not work? Yeah, oh yeah. It doesn't, sadly. Just pouring rain out there. It's hard to like inspect this. I wish I could see the result. I got a state. So I expect, so I care about the ones where, not select. Oops. Bad chaining. So 0, 1, 1, -1, and 2, 0. So 0, 1, 1, -1. So 1, -1 is right. 0, 1 is right. And 2, 0. 2, 0, 1, 1, -1, 2. 2, 0. That's seeing 4. That's not right. Huh? I have 0, 2 rather than 2, 0. Did I do that backwards? What's 0, 2? 0, 2. No, 0, 2 is right. 2, 0 is not right. 2, 0 is this one. It sees 4. This one, however, sees this one, and this one. Interesting. How could that be happening? Binding.pry if dimension, actually no, chords equals 2, 0, -1, -1. Okay, and can look at the neighbors of this. Don't know that that helps us though. Guess we can run this code and see what neighbors does it think. Oh, it doesn't. I should select them. So it says 1, 0, 0, so 1, it says 1, 1, 0, which is this one, yes. 2, 0, which is this one, which is, yeah. And 2, 1, 2, 1. It sees these three, but for some reason it doesn't see this one. What the hell? Thinks this. The one sort of Z and W under this one is not, can't see this one. It should be able to see 0, 0, 0, 0. I mean, we can double check it's in there. Oh, I'm reading this wrong. Oh my god. Okay. 2, 0, -1, -1. Oh my god. 20 is this one, not this one. Come on. So it is actually, this is 20 is good. Yeah. 20 is expected. Okay, let me just look at my test again. Oh boy. So 1, -1 can see 3. Yes. 0, 1 can see 3. Yes. 0, no, 2, 0 can see 3. Okay. Oh boy. So that's right. Yeah, okay. So we're still failing, but we've asserted more things, I guess. Let's take that. Change these to refute. And then swap out the ones we care about. All right. Then we can. Where do I have misalignment here? 2, 0 is right there. 1, -1 is right there. And 0, 1 is right there. So we have 3 assertions, and it's slow, but they all, our whole layer is correct. So that's upsetting and sad to me. But we can make the same assumptions about all of the layers that aren't z equals 0, w equals 0. They should all be the same. So we can do -1, 0, 1 each do. It's not doing an extra cycle. No, just doing the one that we're calling here, taking the initial input and then doing a single cycle. So this is going to make assertions about the entire state of this thing, of all of our friends. And of course, we finally get a failure, which is really good to see. On day 17, 195. So it is expecting some value that I don't know. Let's put rescue on this block. Can we catch assertion errors? Or something in this? No, it won't let us. What did I say? 195. So I can say binding.pry unless this. Cool. So. Actually, that should have been if that. We'll get there. We'll get there. I believe in us. Longest stream on a single puzzle I think we're at here, but we're expecting 2100. to not contain anything. After one cycle. 2100 is just on the regular map here, though. Oh, I made a mistake. We already have tests for zero. We need to next if ZW equals 0, 0. Oh no. What? Did I like miscount? We're getting expected 29, actual 81? What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 23, 26, 29, yeah. That is 29. Is our counting wrong? We worked on it before, but it's conceivable. If we're getting the right results out of this thing. Values. Dot flat map. Values. Flat map. Values. Dot flat map. Values. Dot count. $848. I mean, there's 848. Oh, gosh. 29. Okay, so whatever I've got in there doesn't work. Should have just written whatever I just wrote. And this is the same. This should be the same. Let's not get ahead of ourselves. Oh, hello, hello. Hey, there we go. I knew we were close. And this one is the same. Just so that they're symmetric. That one would have been easier to write as a loop, but anyway. Sure tests are all still passing, and I'll commit this. Cool. All right. Well, that is part 1 and 2 of day 17 done. Took a little longer than expected. Let's see if we can make up some time on the next one, or I may have to only do the 2 that I'm behind and leave the other one for later. Day 17, part 2. All right. Let's get into day 18. Operation order. As you look out the window and notice a heavily forested continent slowly appearing over the horizon, you are interrupted by the child sitting next to you. They're curious if you could help them with their math homework. Unfortunately, it seems like this math follows different rules than you remember. The homework, your puzzle input, consists of a series of expressions that consist of addition, multiplication, and parentheses, just like normal math. Parentheses indicate that expressions inside must be evaluated before it can be used by the surrounding expression. Addition still finds the sum of the numbers in both sides of the operator, and multiplication still finds the product. However, the rules of operator precedence have changed. Rather than evaluating multiplication before addition, the operators have the same precedence and are evaluated left to right regardless of the order in which they appear. For example, the steps to evaluate the expression blah 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 are as follows. You do plus first. Rather than evaluating, operators have the same precedence and are evaluated left to right regardless of the order in which they appear. Oh, okay. So everything's left to right, and okay. Evaluate the expression on each line of their homework. What is the sum of their resulting values? Okay. Okay. All right. We do math wrong. I'm into it. See if we can do a little quicker than that last one. Day 18. I'm optimistic given this problem. So we have a bunch of math. Okay, cool. We can take a sample expression. Let's take this one. First, I want to be able to parse an expression. Parse, module. And then we want a class parser test. Ooh. Really good typing skills here. I'm gonna do two examples. I'll do this as an example because it's easier to begin with. And this one I want to come out as one, or it's just gonna be an array. We're just gonna model everything as arrays. This might not be the easiest way to do it, but we'll start with that. And if we need to change, that should be the number 4 symbol, that, the number 5, the symbol plus, and the number 6. And, do I want to do it like that, or do I actually want to build a tree out of it and just evaluate it as a... Let's do this for now. We'll see where it gets us. And then similarly though, this one has nested expressions. So 2 and 3 need to be in an array. 4 through 6 are in there, and 5 and 6. Evaluating it would be a lot easier if I actually built it let's, I don't know. I'm so torn. Um, ooh. Okay. I mean, this, to get the first test to pass, we can do input split on spaces, and then put split on spaces, and then map so what do we support? Plus and arithmetic? Do we support subtraction? No, just those two. So that should make our first one pass. Oh, nope. Almost makes our first one pass. And then our second one does not pass yet. Oh. What happened to our... That's funny. Okay, so our first one does pass, but our second one doesn't. How are we going to get these out in the structure we need without actually writing a parser or something here? Oh. Yeah, the thought has crossed my mind. I kind of want to do regular expressions though. So I want to try something. So we can have either a number what happens if I just pull the next thing to evaluate at the start of the string every time? So and then it's either a plus or an asterisk, right? Why isn't it matching our second line? Start of string. Does it? Okay. It'll be actually /a in the real thing, but I can just doing that now so I can forget that later and have it mess me up. And then this could be this, but it's not necessarily. That's not what I want though. Can't be dot star. It can be numbers and spaces and pluses and asterisks. Or sorry. Try and match this first one here. Let's ignore this. No matches. That does what I expect. Matches too much stuff though. Ha. That won't work though. That one, dang it, that won't work. I can't. I don't think this could be parsed with the regular expressions. We only support single digits. Do I parse this with a, do I do the recursion? Okay. So if I do input.chars reject, because we don't need the blank ones. Don't need no spaces. It's gonna return us. Yeah, nothing's too simmed. So we have our input. So let's just flip it there. Then we need to parse the first expression till we get an op. So then maybe I want this to just do all the work and say that what I really want is like I'm doing this backwards. Yeah, I'm doing this backwards. Really want is 1 plus, or no, this is right. One plus 2 times 3 is 4 times 5 plus 6. So it's ugly, but something like that. And then this other one is similar, but let's just... Thanks, Jiggins. See you later. Definitely need some water. All right. This is tough. All right, so Do we want to reverse it? Maybe. We got a different result, but it'll just be this with everything reversed, I think. So, so we want to parse so the result is going to be take expression, take operator, take expression. Maybe. So we want to take the 6 or take this. Oh god, this is, I am so parsing stuff like this is not my forte. What do you think about this? I want to just go left to right since this thing is left to right. So I don't think this strategy was what I wanted. I don't know. Let's just try and start coding and see if we get somewhere. Until input dot empty. What do we do? We start by we want to take an expression, right? This might just be an evaluator, but it'd be a lot easier if I just used a parser generator and stuff, but I have literally no experience doing that. So that seems out of reach. equals input dot shift is the first, right? Yeah. So let's just use okay. Get term input, A equals get operator input. Oh, sorry. That should be op. Whenever we're expecting an operator, there's always going to be operator. It's just the term we need to be able to parse is whether it's a number or a sub-expression. So now we can build our first term. That only works in the first case. We know that that's that. And then we can say results. Oh, that's why did I write that? Nil. We can say if result, do something else. Okay, so yeah, it looks like I'm seeing a base case come out of this, or some setup that needs to happen correctly. Okay, does that work for part one? It does. Nice. Now let's try and handle something a little fancier. So let's get rid of all of our extra junk in here. Okay, so this one is evaluated as 5 plus 6 are grouped, and 2 and 3 are grouped. So, and then 4, 5, 6 are grouped. So it's going to evaluate this first, 1 plus 2 plus 3, and then 1 plus 2 plus 3, like that. So we're going to have 6, 7 is there, and then we're going to evaluate 7 plus, I think that's right. And of course this won't work. It's going to generate a bunch of garbage that doesn't work because we've not handled parentheses. This else case. Ooh, evening vibes turning on. So in this case, we know we've hit an open paren. Which I think means that we can call get term. I'm gonna do something similar to what's up here. So I feel like we're gonna end up doing some kind of weird refactoring of the logic to combine it or something, but I don't know how that's going to shake out. But do we need like a parse expression method? Parse expression or something? It's going to do something like this. We have some recursion happening. Maybe. We'll see. See if I'm on the right track here. So this should still pass our first case, but fail our second case. Yeah, that's expected. Get term input. Oh boy. So forgiven. Maybe keep track of depth in here instead of trying to empty it out. So I feel like I've not taken a good approach to this. I know I read a tweet. Someone said that they recompiled PHP with different operator precedents and just evaluated the inputs, which is very clever. I'll give them that. I'm going to mute and eat a cookie. Keep my blood sugar up here. Good cookie. Shout out to my mom. How do we make this reusable? Until the input is empty, or depth. This is your favorite cookie my mom makes. Interesting. These are, I don't really know what to call these. They're like little squares. They're Neapolitan colors, and they're kind of a sugar cookie, but not like a whipped one or something. Or sorry, not shortbread. Sugar cookie, I think you call this. And it's got some nuts and stuff in it. It's good. Or I can, something, it's a tricky one. So got some recursion here, but this can't be input.empty. We have to have a break in here. We hit a okay, so step. Actually, that's not where I want to do that. That's not where I want to do that. Yep, that's fine. So, where are we at? That's what I was suspecting. At this point, if op is one of these, at this point we need to return results. Ooh, okay. Honestly, not 100% today, but getting a little tired of, you know, I've been at this for almost 3 hours. So this is definitely the last puzzle I'm going to do. Maybe I'll try to do 2 in the evening. We'll see. Part 1. Okay, so what was I doing? Now I can parse this thing. So let's just write a solver now. Oh, that's not quite right. Input equals split on new lines, map, problem. Like that. And given a few problems from our input, that one, which is supposed to be 71. Wow, copy. And this one, which is supposed to be 51. And this one, which is going to be a much larger number. So 71 plus 51 plus 13,632 is a big number. And so I can say input dot some. Let's write some nice English looking Ruby there. Cool. Runs, fails. Excellent. Now we just have to implement solve. Easy. So A equals problem 0, op equals problem 1, and B equals problem 2. Try and solve A. How do we do this? How do we do this? If A is a integer, or no, let's see. Case op. When plus, then when multiply, then, and then we return solve A plus solve B, or solve A times solve B. And then we say return problem if problem is a number, right? Sick. All right. See, hopefully part 2 is relatively easy. You managed to answer the child's questions and they finish part 1 of their homework but get stuck when they reach the next advanced math. Now, addition and multiplication have different precedence levels, but they're not the ones you're familiar with. Instead, addition is evaluated before multiplication. For example, the steps to evaluate the expression 1 plus 1, etc. Oh no. Well, that I should have seen that coming, but day 18, part 1, complete. And can't just read it left to right. Dang it. I'm stubborn and I really want to do this, but well, let's write parser 2, see what we get. Try and reason about this. So this one we do pluses first, left to right. So we need to evaluate that first. And we need to evaluate that first. We need to evaluate that first. And then evaluate this. And then we evaluate the other one. So if we can just use a different parser for this one, then we can still reuse everything else. So this one has parens ready, so let's put those in. There, and 2 and 3. And this would be evaluated as 1 there, and then that. Okay. How might we actually go about doing that? So yeah, the first one's just totally wrong. That's to be expected. I think Ruby lets us redefine plus and multiply on numbers. I mean, it's going to break everything, not surprisingly. Yeah, that blew up pretty quick. I think we should do something horrible using Ruby. So let's make a class called badInt that and to do plus other, it goes @int. I guess we're going to have to add a reader for it anyway. @int times other.int. And multiply other is going to do int plus other.int. Adder reader int. Okay. So badInt new with a number times badInt new. Well, it's got to return another. It's got to return a new badInt, but this will work. So this should give us 6. Or sorry, it should give us. Oh yeah, I guess I shouldn't have inherited from integer. That was a bad idea. Okay, let's do something stupid then. Let's skip the parser entirely. And just eval each line, switching out the things for math that or for objects that this is the worst idea I've had in a while, and I really like it. So we've got an example here. So that line is 231, and this line is 51, and is some big number, so we're expecting 231 plus 51 plus 23340 as the result here. And we're about to do some programming crimes. I would never do this in a regular application, but this isn't a regular application, so YOLO. So let's not parse the inputs, just have them as a bunch of lines. We need to implement a class called badInt, which takes a number, keeps track of that number, has an adder reader for that number, and when you in fact, we can even better. We can skip all that. We could even write tests for it. So let's do that. Oh, forgot to do. So test equality. So I want to say assert equal badInt. That new 3 badInt new 3 refute equal, and now I should get this out of the box with okay, excellent. Def test multiplication. And so this should equal 7. Do not know how to type, but that won't work because it doesn't have that method. Excellent, that works. And then need to test addition. And we want to assert that this equals 12. And I'm still running part 1 for some reason. So let's run part 2 and see it continue to error. Oh, test addition. I didn't actually do it. Getting ahead of myself. Okay, so now for the terrible thing we're going to do. We're going to go input.sum, do problem, and then now eval in Ruby I can do like 1 + 1, yeah? Cool. So we're going to eval the problem, but we are going to gsub now this is where I could use my friend Rubular. Oh, I'll just use these examples. We want to gsub every. I'm sorry, that's into. Can I use my captures in gsub? I want to do a proper yeah, that's what I want to do. So gsub and we replace it with bad int.new /1. Okay. Char. Okay, so that's not actually right. Oh, it's a single. It's because I used double quotes. Not cool there. Bad int can't be coerced into integer. Intriguing. Well, let's take a look. Got it. Once I val it, I need to convert it back into a normal integer so that it can be summed. And I don't get the right result though. Dang it. Well, I'll test this to see if somehow. Not the right answer, too high. Okay, why would this not work? Isn't 270 the right answer for, no, it's not. Hmm. 1, 2, 3, 4, 5, 6. So my thought was that by reversing what the operations do. Oh, but I need to swap the operations in the actual string too. Okay. Is there any easy way to do that without doing the 3-step swap occurrences of... Oh, there's string tr, I think is what can help me here. Yeah, and oh, I don't know what I'm clicking on. So I can swap all the occurrences of plus and that. Oh, this is the worst thing I've done so far. This is why we love Ruby, you know? This probably is right, isn't it? Yes. All right. There it is. Oh, do I want to? I might come back and do whatever, day 19 or something before my evening stream. But that is it. I just did maybe the worst thing I've done with Ruby, which was implement a numeric class that has multiplication and addition working the opposite way, and then it basically just evaled all this code using my terrible class and swapping the operations so that the precedence would be right, even though the operations were all backwards. I love this so much, but thanks for coming, everyone. See you again later this evening.